Welcome everyone and welcome to the AluVET vocational training and education for the aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, heat treatment, and how it is rolled, extruded, and/or welded. And in this module, we shall be looking and understanding how international standards work and looking for an explanation of aluminium wrought coding systems throughout international national standards. This project is funded with the support of the European Union. This publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. The purpose of this module is to explain the international system of classifying aluminium wrought standards and the coding of their alloys by their chemistry. To explain the international system of aluminium wrought alloy coding and the relationship between European and national standards. Wrought is a word that means mechanically worked, shaped, or beaten. Having completed this module, you will understand how aluminium alloys are coded. You will understand the relationship between international and national standards, how the individual aluminium alloys are unique, and how the codings are internationally agreed and applied. You have an insight in how the standards specify the chemical composition limits for each alloy. You will know where to seek information about the coding of aluminium wrought alloys and their chemistry from international and national standards. And from the coding of the individual alloys, you'll be able, from national specifications, standards, to find their chemistry. Aluminium and its alloys are by international and national standards divided into two broad classes: wrought and casting alloys. We are concerned and will be learning about the first major division, that is wrought alloys. And wrought alloys are those that are mechanically worked by rolling, extrusion, forging, pressing into desired shape. The second major division are casting alloys, those that are poured in a molten liquid state into a mold, producing a cast shape. We will only be talking about wrought alloys. All wrought alloys are classified, coded, allocated, and controlled internationally by the Aluminum Association through global agreement of all the world aluminium industries and by all national standard bodies such as European standards and British standards. Now, I'd like you to note that we are talking about the Aluminum Association, and when we talk about the Aluminum Association, we use the American way of spelling, which is NUM. The Aluminum Association is based in Washington, D.C., and in 1954 introduced a four-number coding system for all wrought aluminium alloys. And the Aluminum Association maintains an international register system entitled International Alloy Designation and Chemical Limits for Wrought Aluminum and Wrought Aluminum Alloys. The Aluminum International Register lists all internationally recognized wrought alloys. And the register is known as teal sheets. Now, teal is a deep blue-green color, and the aluminum alloys were originally printed and listed on teal-colored paper to separate wrought alloys from other alloys. Hence, the system is known as teal sheets. Most international aluminium committees, such as European standards and British standards, and all major companies in 1970 adopted the aluminum the four-number system of classifying aluminium alloys. Hence, all European standards follow the Aluminum Society, as indeed do all national standards. So whether they are DIN, JIS, or British standards, they will all use the same four-number digit to identify alloys and within the same chemical composition limits. The teal sheets are the central record of all international alloy designations and the chemical compositions for all wrought aluminium and wrought aluminium alloys. And the Aluminum Association registration record is the defining source for the designation and chemical composition limits for wrought aluminium and wrought aluminium alloys referenced in all national and international specifications. What I'm saying is that European standards, British standards, or refer to the Aluminum Association teal sheets as the primary source of the coding, the four-digit coding of all alloys. If you need to check any four-digit wrought alloy, your customer asks you for an odd alloy that you don't know, you can access the Aluminum Association website in the website given there. And if the alloy is listed, then it exists in the world and it will be referred to by your own standards. The Aluminum Association register contains over 350 alloys, and manufacturers and national standard bodies like European standards can propose new alloys, which are then vetted by all the other Aluminum Association member countries and members. For a new alloy to be internationally recognized and coded, that is to be given a four-digit, a four-number code. It has to be significantly different to existing alloys. There has to be greater than a 10% change in its chemistry, and the properties of that alloy must be fit for service, not deleterious. Now, there are some exceptions to the 4-digit numerical system for new alloys. And that's for alloys that are commercially important, but whose chemistry or tweaks are not sufficiently unique to justify a subcode. And in that case, the Aluminum Association or European standards will add a 5th digit, a letter. So American alloy 2014 is very, very similar, but not identical to the European alloy 2014A. The 2014A has slightly different chemistry, but not sufficient to be awarded a new number. So the four numbers that code all aluminium raw alloys are unique.